Here's problem number 62. It's a doozy, so bear with me. We start with this equation and we're asked to find what the second derivative is with respect to x. So first we'll take the first derivative and we end up getting that 2x minus first times the derivative of the second plus the second times the derivative of the first, which is 1, and then 2y dy dx is equal to 0, the derivative of 1. Distributing that negative sign through, we end up getting that 2x minus x dy dx minus y plus 2y dy dx is equal to 0. Let's collect the terms. The 2y and the negative x stay on this side, and we factor out the dy dx. Onto the other side goes the negative y, which turns into positive, and the 2x, which turns negative as we go over there. And then we end up with that dy dx is equal to y minus 2x all over 2y minus x. And that's actually problem number 61, and that's correct. Now, the big job is to get the second derivative. Now, I'm going to use an alternate notation just because this is going to get pretty wild and crazy. Let's describe this first derivative as y prime. And now we've got y prime, and I'm going to take the derivative of it and get y double prime, which is equivalent to finding the second derivative with respect to x. And I'm going to do the quotient rule on this quotient. So I get the bottom times the derivative of the top minus the top times the derivative of the bottom. And every place that I would have written dy dx, I'm simply writing y prime. And that whole thing is over 2y minus x quantity squared. Now, I'm going to use FOIL method and expand this out and see if anything nice happens. I get 2y y prime minus 4y minus xy prime plus 2x, and now I'm going to do the same thing here, minus 2y y prime minus y minus 4xy prime, and ending off with a plus 2. Now when I distribute that, and all of this is still over 2y minus x squared. Now if I distribute that negative sign through, and negative there, positive there, negative there, and doing that, we are going to see that 2x and that 2x cancel, and this 2y prime and this negative 2y prime cancel, giving me now a negative 4y and a positive y, and a negative xy prime and a positive 4xy prime. Combining these two terms together, I get 3xy prime, and combining those two terms together, I get a negative 3y, and this is all over 2y minus x squared. Now at this point I've got to get rid of this y prime, which means I'm going to have to substitute what y prime is equal to, and that looks like this. I get, well, first of all, I'm going to write the denominator here separately. And then over here, I'm going to write 3x times, and I'm going to write what y prime is equal to, which is y minus 2x over 2y minus x. And then I've got the negative 3y, but I'm also going to find its common, you'll get the common denominator again, 2y minus x, 2y minus x. Now when I do that, let's see what happens. I get a 2y minus x squared out in front still. I distribute this 3 through all those terms, the 3x through those terms, and I get 3x. You know what? I'm going to take that 3 out right now. Take the 3 out there. We'll pull it there, and that will make things a little bit nicer. There we go. Alright, now I'm going to distribute the x through, and I get xy minus 2x. And then over here, I get negative y squared and a positive xy. And that's all over 2y minus x. Well, you may notice here 2y minus x and a 2y minus x. Let's collect those terms. So 3 over 2y minus x cubed. And now over here, I take a look at what I've got. And I missed something here. Y times 2y is negative 2y. X times negative 2x is negative 2x squared. That looks better. Alright, I've got a negative 2x squared. I've got these two xy terms giving me positive 2xy, and I've got this negative 2y squared there. Now you can see the 2's are a common term. I'm going to factor out a negative 2 out of all of that. And why would I do that? Because that leaves me with x squared minus xy plus y squared. And by our original equation, way up there, that's equal to exactly 1. So we end up with negative 6 over 2y minus x quantity cubed, which happens to be answer A.